Hello everyone. In today's video, we'll cover linear regression. Um, what we try to do in linear regression, we find a linear model that describes the relationship between a dependent and one or more independent variables. So we might have several input features, and then we try to find a linear model that best describes the relationship between the features and the output or labels data. So in case we have one feature, so the equation would look like this. So y is equal to a0 plus a1 x1. As you could see that this is the equation of line that we are familiar with. So a0 here is the y-intercept where the line intersects the y-axis, whereas a1 here describes the slope of the line. And when we have more than one feature, so we have the equation in this form. So a0 plus summation from I is equal to 1 to n on ai xi. Um, we could solve these kind of problems using normal equations. So let's see how we can do that. We could write this equation in matrix form like this. So we have vector y showing all the y values. So we have my values here. Then we have this matrix here, and which is being multiplied by another vector of coefficients that we are trying to find. So if we look at this equation, so y1 should be if we multiply this row by the elements of this column, so we end up an equation similar to this one. So a0 plus a1 x1 plus an x1. So the superscript here is just describing the number of features. So in this example, since we have n features, so we have n plus 1 columns here. Okay, so in short, we could write the same matrices vector product, matrix vector product like this. So y is equal to xm. So m is the coefficient vector for the model, and that's what we are trying to um, determine. So we um, left multiply both sides by x transpose, then we left multiply both sides by x transpose x inverse. So here we have x transpose x inverse multiplied by x transpose x, so which will result into an identity matrix multiplied by m will result into m again. So m is equal to x transpose x inverse multiplied by x transpose uh, multiplied by y vector. So the example that we will try to solve in this video uh, is given here. So we have three tasks to do. We'll generate a data set, so XY pair, so only one feature for this example of size n is equal to 100. Um, so we'll generate 100 examples with intercepts so equal to 2 and slope equal to 4. So we'll generate a linear data set, this equation here. So a0 is equal to 2, whereas a1 is equal to 4. And then we'll add Gaussian noise to this data set. So once we have our noisy data set prepared, we'll try to find a linear model using these normal equation um, that best describe the input data set. And once we have our linear model, we'll use that model to predict the y value at x is equal to 7.4. Okay, so this is the example that we'll look at today. So let's get started. First, here we are importing all the uh, required libraries and functionalities. So we import NumPy as an NP, and then from Scikit-Learn linear model, we'll import linear regression. And for plotting, we'll also import matplotlib pyplot as PLT. So we run this first cell, uh, create another cell. So we start with n is equal to 100. Then we generate x values. And for this example, yeah, we'll restrict the x values from 0 to 5. So np random.rand, and we'll generate 100 examples. So the intercept and slope that we want to use are 2 and 4 respectively. So once we have that, we need to also generate some Gaussian noise or normal distribution random noise. So 100 samples of that too. So then we could generate y, which would be intercept plus slope times x plus the generated Gaussian noise. This is our input data, so that is task A. So let's run this. Okay, we'll create another cell. And so now we need to find a linear model that describes the input uh, XY data set. Okay, so first let's create this matrix here, matrix X. So it should um, be of the form 1 and the feature that we have. So in this case, we only have one feature. So we could create this matrix using NumPy column stack, and NumPy ones like X, and then we want in the second column um, X, that is the feature set. So this is how we'll generate X, and let's look at the first 5 rows of this X. Sorry. So this is how it should look. So the first column is comprised of ones, and then the second column is the X values that we generated here. Okay, so once we have that, we could simply calculate the model coefficients using the normal equations. So for that, we'll use P inverse um, from the linear algebra and NumPy. So xt dot of x, and then we take dot with xt, so the transpose of x, and finally take another dot with y. And let's look at the values of m that we got here. So the first one here is the slope intercept value, and the second one represents the slope uh, parameter. Okay, so we got the model coefficient. Uh, Now we'll use this model coefficients to predict the values. So first let's predict um, the values over the entire X range just to see where um, uh, the model predictions lie as compared to our input data. So for that, let's first create um, a lambda function. So lambda x should be, so first one is intercept plus slope uh, and time x. So that's what we want to predict the model. So let's run this one. So then y hat will be simply predictions on x, and that should return this. And you also want to predict at 7.4. So let's see what value do we get. Um, and we will be getting 31.73 from our model. And let's plot this y hat along with the input data just to see how good the model fit is. So this is how the input data looks. So all these um, red squares here, and the linear model that best describes our data is this line here. Okay, so this is linear regression using NumPy. So we could also use scikit-learn linear regression, um, and that is even um, simpler than the NumPy approach. So we could apply, so create an object, linear regression object, then fit this to our XY data. And once we have that, so we could check the intercept and the model coefficient using reg intercept underscore reg regularizer coefficient underscore because we named it reg here. So you could see that we got the same intercept and slope values here. Um, so prediction is also uh, very simple in this case. So we only need to write reg predict, and then we need to provide the um, x value, so which was 7.4. And if we run this cell, so we get 31.7315. So in the previous case, we also um, got 31.7315. Okay, so this was all about linear regression in this video. I hope you liked it. Uh, and thank you for watching, and see you all in the next video.